Good morning, students. I welcome you to the class 9th bridge course. What is bridge course? Science is all around us. What is science? Science is all around us. It is the subject study of how things around us work. You know that science has been divided into three branches that study specific things. Science is divided into main three branches: physics, chemistry, and biology. Okay? Now in this unit we will learn about some important concepts of physics, biology and chemistry that you will need to know to understand class 9 syllabus. These are the important topics that will be covered in the physics bridge course: measurement, motion and force. In biology, cell structure and types, nutrition, microorganism and habitats. And in chemistry, mixtures, separation of mixture, physical and chemical change. So now let's begin our physics bridge course by recalling how the measurements of length and distance is made. Measurement of length. How does a tailor know how much cloth will be required to stitch your shirt? Think about it and write. How does your tailor know? Tailor will take the measurement of the length of your arms, backs, shoulder and so on to decide how much cloth will be required for stitching your shirt. When you go, he use measure tape to measure the length of various parts. When you go to tailor to make a cloth for you, then he will take your hands sleeve size, back size, neck size, shoulder size, and then according to that he will require the cloth to stitch that is in your shape, that is at your length, or and he uses measure tape, yellow measure tape, to measure the various parts of your body. How does a carpenter know how much wood is required to make a piece of furniture? The carpenter would either use a ruler or a tape to measure the length of the wood. We need to make measurements in our daily lives for many purposes. For example, a tailor needs to measure the length of cloth and carpenter needs to measure the length of wood. Now, need for measurement. What is the need? Mohit wants to go to Soham's house from the school. How will Mohit decide if he would walk to Soham's house or take a bus? મોહિતને સોહમના ઘરે જવું છે સ્કૂલથી, તો એ કેવી રીતે ડિસાઇડ કરશે કે એ સ્કૂલેથી સોહમના ઘરે ચાલીને જશે કે બસથી જશે? તો મોહિત will estimate the distance between his school and Soham's home. So first what Mohit will do is કે પેલા સ્કૂલથી સોહમના ઘરનું ડિસ્ટન્સ જોશે. હવે ડિસ્ટન્સ વધારે હશે તો એ બસથી જશે, ડિસ્ટન્સ ઓછું હશે તો he will walk. If the distance is more, he will take a bus. If the distance is less, he will walk. Let us do an activity to understand how measurements are made. Measure the length of your desk using handspan. Place your hand along the length of the desk and measure it end to end. So you know how to use handspan method. The thumb and the last finger of your hand, use this as a measurement. This is handspan and use this as the measurement this way, and uh, you can measure any object. So try to measure any object or any desk you have, or an sofa or anything, or a board. Measure it. What is measurement? When making a measurement, we compare an unknown quantities with known fixed quantities. Right? Here, the known quantities was the length of the desk and the known quantity was handspan. Unknown was length of the desk and known is handspan. When we make a measurement, what we do? What is measurement? Like we compare some unknown quantities that we can compare with the fixed quantities. So when we compare with the desk, we can say here the length of desk is unknown and known quantity is handspan. Any measurement has two parts, a number and a unit. Suppose the measurement of a desk was 5 handspan. Here then 5 is a number and 1 handspan is a unit of measurement. તો મેજરમેન્ટના બે પાર્ટ છે, એક નંબર પાર્ટ અને એક યુનિટ પાર્ટ. સપોઝ એને એક્ઝામ્પલ આપ્યું છે કે 5 હેન્ડસ્પેન એક મેજરમેન્ટ આવ્યું ડેસ્કનું. તો 5 ઇઝ એન નંબર એન્ડ હેન્ડસ્પેન ઇઝ the unit, basic unit in which we are saying that in one handspan that is 5 times used to measure the measurement of the desk or length of the desk. A unit of measurement, a non-fixed quantity which is used for measurement of an unknown quantity is called a unit. It is a known quantity with which an unknown quantity is compared. So what is unit of measurement? A known fixed quantity which is used for the measurement of unknown quantity. એટલે જે કોઈ બી એવી ક્વોન્ટિટી જે તમને ખબર છે જેને તમે યુઝ કરીને અનનોન ક્વોન્ટિટીનું મેઝરમેન્ટ ફાઇન્ડ કરો છો એને યુનિટ કહેવાય છે. And basically what we are doing, we are comparing known unit with unknown unit so we can know the measurement of unknown unit. So we are comparing. Check for understanding. A large field measures 100 meters in the length. What is the unit of measurement? Here the unit of is meter. Here it is given 100 meters in length. So we know the basic unit is meter, and what we are comparing it with the field. So field is 100-meter long. We know the basic unit is meter and n is the number here. So why were your measurements of the desk different from other around you? So if we are doing this activity in a pair, then but you can take two other objects and you can measure, or you can do that. Take one object and try with your hand and and try tell your parents also to do that, so you can see the difference. And that difference is because your father's or any family member's hand will be bigger than yours, fathers or grandfathers, than as compared to you. So it will take a less measurement for one handspan compared to your handspan. So handspan will vary different length for every person. So this is not the standard unit of measurement. So length is not same for every person if we use handspan method. If two people were to measure the length of same object using their handspan, that they will not get the same value. So we need some specific fixed amount, fixed length that is common for all in the world to measure something, right? Standard units. So for that we have standard units of measurements. To make that measurements made by different people across the different state or even countries are uniform, we need a standard unit of measurement. For all the world, for all the people in the world, we want to make that all the units are uniform, all the measurements are uniform. Then for that we need a standard unit of measurement. A standard unit of measurement is a unit that is fixed and same for the people all over the world. As I already told, it should be fixed and same for all the people in the world. So we have learned that we need standard units, standard unit of measurement to maintain the uniformity with the people. So now let's study some standard unit of measurement which is now used by the world. So standard unit of the measurement. The standard unit of measurement is a unit which is uniform for everyone all over the world. It is a unit of measurement which has fixed value and which does not change from person to person or place to place. This unit of measurement, it has its fixed value and we cannot change its value if we go anywhere in the world. If we talk to another person, for that also it is the same, and if we go to another place like anywhere in the world, it will be the same. What is International System of Unit? What is SI units? Scientists all over the world accepted a set of standard units of measurement. This system, now worldwide, is known as the International System of Units. SI units. It has seven base units such as meter, kilogram, second, and so on, which are used to measure different types of quantities. So scientists have accepted, all the scientists in the world have accepted that there should be some standard units to measurement for holes perform the uniformity. So the worldwide now has accepted that this should be done. This system should be accepted. So there was International System of Units. So it is known as International System of Units, SI units. And in that there are seven base units like meter, kilogram, seconds, and many more, Kelvin, ampere, and many more. Right? So let us learn about the unit. The SI unit of length is meter. Like for example, the length of the table is 1 meter. ટુ ટુ મેજર એની લેન્થ, કોઈ ભી લંબાઈ માપવા માટે મીટરનો યુઝ કરીએ તો એસ અ યુનિટ મીટરમાં લેન્થ ટુ ફાઇન્ડ આઉટ એની લેન્થ વી યુઝ મીટર. To find out any time we measure in second. For example, time taken by a swimmer to swim from one end of pool to the another end is 7 seconds. So SI unit of time is second. કોઈ ભી ટાઈમનો મેજરમેન્ટ માટે કોઈ ભી જગ્યાએ સેકન્ડનો યુઝ થાય છે. Interesting fact, the SI unit of length meter was defined as 1/10 millionth of a distance from the North Pole to the equator of the Earth. Scientists then made it worldwide. 1 meter is equal to 1 upon how many? 1 crore. Distance between the North Pole and the equator line. So here it is Earth, and from North Pole to the equator line the distance is 1 upon 1 and 7 times 0. Right? That is the distance. That short is 1 meter. So it's an interesting fact. Right? What is the distance between the North Pole and the equator? That is 10 million meters or 1 crore meter. That's why we divide 10,000 meter with uh, 10,000, no sorry, 1 crore meter with 1 crore, we get 1 meter. What is the distance between North Pole? North Pole is at the top of the center. Here you can see this is the North Pole here, and equator line is here. So the distance is 1 crore meter, right? What are the divisions on a ruler called? Here the division on a ruler refers to centimeter and millimeter, right? In this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these are centimeters, 1 centimeter, and in between 0 and 1 there are small lines and they are millimeter. This small distance is 1 millimeter. You can see here in the zoom figure. This is 1 millimeter. That is the distance between this 0 and 1. You can see. How many centimeters are there in a meter and how many meters are there in a centimeter? 1 meter is equal to 100 centimeter and 1 centimeter is equal to 10 millimeter. Here in the scale you can see, here 1 centimeter is there and this is equal to 10 millimeter. 1 millimeter, 2 millimeter, 3, 4, 5, 6, 7, 8, 9, 10. So 1 centimeter is equal to 10 millimeter and 1 meter is equal to 100 centimeter. Do you know how many meters are there in the kilometer? 1 kilometer is equal to 1000 meters. 1 1 kilometer is equal to 1000 meters. Now you write all this 1, 2, 3 questions. Here one, how many meters, centimeters are there in the meter, millimeters are there in centimeter, and how many meters are there in kilometer. Write these three questions in your notebook. This is the first homework. More I will give. Which unit will make it easier to measure the following distance and why? The distance between Mumbai and Kolkata, the length of your textbook, the width of a shoelace, the length of a school building. So the distance between Mumbai and Kolkata is larger, so it's easier to use kilometer to express it. The distance between Kolkata and Mumbai is 2000 kilometer. For the length of the textbook, the length of the textbook is smaller than meter but larger than centimeter, so it is easier to use centimeter to express it. The length of the textbook is 20 centimeter. The width of a shoelace, the width of a shoelace is smaller than centimeter, so it is easier to use millimeter to express. Here the width means this one, this part. It's not, this is the length, this is the width, so it should be smaller than centimeter. So the width of the shoelace is 5 mm or millimeter, 5 millimeter. The length of a school building, the length of a school building is more than meter but less than kilometer. Here therefore it is easier for us to use meter to express this. The length of the school building is 50 meter. Conversion of unit. We can see, use the conversion of diagram given below to convert one unit to another unit. So 1 kilometer, we know that 1 kilometer is equal to 100 meter. Then 1 meter is equal to 100 centimeter, which is equal to 1000 meter. 1 centimeter is equal to 10 mm. How we can do? If we want to convert kilometer into meter, we multiply kilometer into 100, then we can get 1000, then we can get meter. If we convert meter into centimeter, then we multiply meter with 100, so we can get centimeter. If we convert centimeter into millimeter, we multiply it with 10, so we can get mm. So let's take an example. I want to convert 5 kilometer into mm. How I will convert? So we need to multiply 5 kilometer into 100, no sorry 1000, to convert into meter. So 5 kilometer will now converted into meter, which is 5000 meter, right? Now for 5000 meter I need mm, so meter to centimeter, so I will multiply this more into 100. So what I will get is 5, 1, 2, 3, 4 and 5 zeros, right? 3 of this 1000 and 100 of this, so it is 5 lakh centimeter. Now to convert centimeter into meter, we will multiply it by 10, so we will add one more zero, now which is 50 lakh, right? So 5 kilometer is equal to 50 lakh millimeter, right? So likewise, vice versa, if we want to convert mm into centimeter, we divide it by 10. If we convert centimeter to meter, we divide it by 100. If we want to convert meter by into kilometer, then we divide it by 1000. So to from larger unit to smaller unit, we multiply, and from smaller unit to larger unit, we need to divide it by. Okay, same ways if I do like this, if I want to convert 50 lakh mm into kilometer, this is mm, I want to convert this into kilometer, so I will first divide it by 10, so 1 0 will be gone. Now this is centimeter, right? Now if I convert 5 lakh centimeter into meter, 2 we have to divide it by 100, so again 2 zeros cut, so which is left with 5000 meter. So 5000 meter is left. Again if we want to convert this into kilometer, we divide it by 1000, so 3030 cut 1505, so which is left as 5 kilometer. So likewise we divide it, right? If we want to convert from kilometer to meter, we multiply, and if we want to divide, if we want to go from smaller unit meter to kilometer, we divide. So remember the relation between kilometer and meter, meter and centimeter and millimeter. Write this relation: 1 kilometer is equal to 1000 meter, 1 meter is equal to 100 centimeter or 1000 mm, and 1 centimeter is equal to 10 mm. Write this three relation in your notebook also. Okay. Now, as we learned the standard units, let's try some questions. Conversation of units. First, practice question 1. Use the conversation diagram given below to solve the following problems. How many centimeter are there in 20 meter? Here 20 meter is given and we need to convert into centimeter. So, be here, let's write. Here it is 20 meter. To convert into centimeter, what we do, from meter to centimeter, we multiply by 100. So 20 into 100, which is 2000 centimeter, right? So this is 2000 centimeter. Convert 700 centimeter into meter. Now it is saying to convert 700 centimeter into meter. So relation between centimeter and meter is 700 centimeter into meter. So we divide it by 100 here. So 700 divided by 100. So which is 0 0 cut, 1 7 plus. So 7 meter. 700 centimeter is 7 meter. Right? Got it, guys? If you have any doubt, please feel free to call me. How many millimeters are there in 34 meter? How many millimeters? Now they are asking you to convert uh, meter to millimeter. Okay, so 34 meters, that for to convert this into centimeter, we need to multiply by 100. So it is 3400. And now in convert, this is centimeter, 3400 centimeter. Now convert into millimeter, multiply by 10, then it will be 34000, which is 34,000 millimeter. Okay, now convert 12,000 meter into kilometer. 12,000, so here it is 12,000 meter. To convert meter into kilometer, we divide by 1000, so we divide it by 1000. So if we cut 3030, what is left? 12. So 12 kilometers. So if we convert 12,000 meter into kilometer, we get 12 kilometer. How many millimeters are there in 1.34 kilometer? So the answer, we have to find 1.34 kilometer into millimeter. So here it's 1.34 kilometer. For kilometer, we need to multiply into by 1000. So we can get answer 1340, right? Because 2 points here, so point 1, if we want to remove point, we need to multiply by it by 100. So 100 and 10 is left, so 1340 meter, then into 100, which will give us 134000, right? 1 2 3, yes. And now if we want to convert this into millimeter, so 134000 into 10 again, so which will give us 134, 4 times 0, so which is 13,40,000, right? So this is the answer. So like this way we can convert kilometer to meter, meter to centimeter, centimeter to millimeter, or vice versa, or directly meter into millimeter, or likewise. So here are the answers. Just check it out. I already tried to solve everyone, but there are the answers. Arrange the following in ascending order. Now we have to arrange this into ascending order. So if we want to arrange some number, then we can easily arrange in the ascending order. Here are the numbers but which has different units. So how can we arrange? So if we have all units same, the first is 25 kilometer. If we convert all the other units into kilometer, then we can directly compare and arrange it in the ascending order. So first we will need to convert all this into ascending order. First is 25 kilometer, second is 2600 meter. So let's convert 2600 meter into kilometer. Here 2000 meter. If we need to convert this into kilometer, what we will do? We will multiply, we will divide it, sorry, 2600 meter, we multiply this by 1000, two zeros cut, two zeros cut, which is 2.6 kilometer. So 2600 meter is 2.6 kilometer, right? Now if we convert 24,000 centimeter into kilometer, 24,000 divided by 100. So now this centimeter is converted into meter, right? 00, which is 240 centimeter. 240, 2400 divided by 100, which will give meter. So 240 meter, and convert this into kilometer. We divide it by 1000. So the answer will be 0.240 kilometer, right? Okay, now let's check. Now we can arrange all this in ascending order. So let us convert all the above quantities into single unit kilometer. The first quantity is 25 kilometers, is already in kilometers, so we leave it as it is. For the second quantity, 2600 meter, we can convert into kilometer as follows. So 2600 meter divided by 1000, so we can get 2.6 kilometer. For the third quantity, 24,000 centimeter, we convert into kilometer as follows. 1 kilometer, then we convert centimeter into meter and meter to kilometer. So we can get answer 0.24 kilometer. The fourth quantity is 210000. So this is mm. We need to convert into kilometer. So first divide it by 10, then it will convert into centimeter. So this is now centimeter. 210000 is centimeter. 2,10,000. If we convert divide it by 100, then this will be converted into meter. 00 cut. This will be meter. Now 2100 is in a meter form. Now more divided it by 1000. So 2 zeros 20 cut. So 2.1, 21 divided by 10, which is 2.1. So 2.1 kilometer is now uh, came from 2000, came from 21, sorry, which came from 21 millimeter, right? 21 lakh millimeter. So the other quantities, like, they are arranged in, first is 25 kilometer, then second was 2.6, then 0.4, 24 and 2.1. So first will come ascending order. So first the lowest is 0.24 kilometer, which is 24,000. Here it is. Now then 2.1, and then after 2, then after, here it is 2.6 kilometer. Sorry. So first is this, second is this 2.1 kilometer, third is here back side, this is third, and this is fourth. Last 25 kilometer is the largest one. 2.6 is smaller than 25, and 2.1 is smaller than 2.6, and 2.0.24 is smaller than 2.1. 1 kilometer. So this is how we are arranging quantities in ascending order. Now filling the blanks. So you need to fill these blanks and write also this also in your notebook, and that questions, this question, arranging this also. Write this all practice question in your notebook. So 61 kilometer into meter. So we multiply kilometer into meter, we multiply it by 100. So it will go 61,500 meter. 24 centimeter into millimeter. So multiply it by 20. So 2400 millimeter. 1300 centimeter into kilometer. So for 1300 we divide it by first 100 and then after 1000. So we divide it with that 0.013 kilometer is answer. 1250 meter, that convert into kilometers. So meter to kilometer we divided it by 1000. So 1.25 kilometer. And 2.35 meter converted into millimeter. Meter to millimeter, so multiply it by 100, then centimeter, and then multiply it by 10, that will give millimeters. So it will 2350 meter millimeter. Okay, arrange the following length as an ascending order. Same process. See here all the quantities, convert them into meter. So 5000, 50,000 centimeter divided by 100, then 500 meter. Then here is already 120000, which is 1,20,000 is already in meter. So we leave it as it is. And 23.4 kilometer, for kilometer to meter we multiply it by 1000. So 23,400 meter. Now we can arrange this in ascending order, right? So this is the answer. Write this all practice question in your notebook. In the first unit of physics in class 9th, we are going to study how to describe motion. So let us recall what we know about the state of rest and motion. Right? We studied in previous classes. So if I say, look at the sofa you are sitting in, so is that sofa at a rest or in a motion? We can see that sofa is at rest, it is not moving, right? So when the second question, if I ask that when we see that ceiling fan is in the room and it is switched on, when we switch on the ceiling fan, then the blades of the fan are at rest or it's moving or it's in motion. Yes, we can say that the blades of a moving fan are in motion, it is rotating. So to decide if an motion is at rest or in motion, sorry, if to decide if an object is at rest or in motion, we observe whether its position changes with time or remains constant. So let us study more about it. State of rest and motion. State of motion. Objects like car, aeroplanes and ship are said to be in motion when any of the following happens. They move away from the point and change its position. They move away from one position and return to the same after same interval, certain interval time. See, plane is moving from one place to another. We can say that, so a plane is in motion. A car is moving in a circular path, comes back to the same position after some time. See here, car is moving from one point. If the car is moving from here, it is going here and turning a circular path and again coming back to this position, but it is in certain time. So it is back to the same position but after certain time. So this car is also moving. Are all objects allows moving? Of course not. When object is stationary in time, it is said to be at rest. When a car is parked in a parking lot, it is at rest. While traveling in a train, do you see a fellow passenger to be at rest or in motion? Do you feel that the trees that you are passing are moving in a opposite direction? When we travel in a moving train, it seems like people traveling with us are at rest. From our perspective, they seems not to move or seem to be at rest. People seem to be at rest in a મૂવિંગ ટ્રેન. જ્યારે કોઈ ટ્રેનમાંથી આપણે જતા હોય છે ને આપણે જોઈએ છે તો સામે કોઈ બી વ્યક્તિ બેઠું હોય એ બેઠું જ છે, એ રેસ્ટ પર જ છે એવું રીતે લાગે છે આપણને. અને two people standing on the platform when a train passes them, it seems like people in the train are moving. To the people in the train, people on the platform seems to be in motion. People on the platform seems to be moving for someone inside the train and vice versa. એટલે જ્યારે ટ્રેન મૂવિંગ ટ્રેન એક પ્લેટફોર્મ પરથી પાસ થાય છે ત્યારે we are at rest but actually we are moving, so we can see that the people on the platform are in motion but actually they are at rest, and the people sitting on the platform they see train or the people we are moving, right? From a moving train, it seems that trees outside are moving, but to a person or a platform, that trees seems to be at rest. Trees seem to be moving for the person moving it from the train. જ્યારે તમે ટ્રેનમાં બેઠા હો ને બહાર જોતા હોય તો ટ્રેનમાંથી બધી ટ્રીઝ આમ આપણી સાથે દોડતા હોય ને પાછળની બીજી ડાયરેક્શનમાં ઓપોઝિટ ડાયરેક્શનમાં જતા હોય ને એવું લાગે, પણ actually we are moving in the opposite direction and trees are at the rest. Similarly, when we are in a moving bus, all the passengers seems to be at rest. However, for a person on the road looking at the passenger bus, it seems that if all the people in the bus are in motion, right? એટલે if we see similarly in this ways, જ્યારે આપણે બસમાં બેઠા હોય અને આપણે બહાર જોતા હોય ત્યારે બહારના પીપલ આપણને એમ લાગે છે રેસ્ટમાં નથી. ઇફ દે આર સમવન ઇઝ સિટિંગ, વી એકચ્યુઅલી આપણે મૂવ કરીએ છીએ, વી આર ઇન મોશન. અને બહારના પીપલ જે બેઠા છે જે આપણને જોવે છે they think we are all in motion, actually we are in the motion. Conclusion, we can say that depending on where they view it from, two people may think differently about the state of an object. હવે એક જ વસ્તુ બે રીતે જોવાય છે, તો કન્ક્લુઝન એ આવે છે કે આપણા ઉપર ડિપેન્ડ કરે છે કે આપણે ક્યાંથી જોઈ રહ્યા છીએ, આપણે મૂવિંગ ઓબ્જેક્ટમાંથી જોઈ રહ્યા છીએ કે આપણે બહાર બેસીને પ્લેટફોર્મ પરથી જોઈ, એના ઉપરથી સેમ વસ્તુના ટુ પર્સપેક્ટિવ બને છે, રાઈટ? So can we appear at rest and in motion at the same time? Explain with an example. We can appear at rest and in motion at the same time to two different people. For example, when we travel in a car or a bus, we appear at rest to our fellow passenger, but we appear to be in motion to any person standing outside the car or bus. એવું પોસિબલ છે કે રેસ્ટમાં બી હોય અને મોશનમાં બી હોય સેમ ટાઈમ પર, આ એક્સપ્લેન કરવાનું છે. તો વી કેન સે દેટ વાય, because if we are traveling in a car, આપણે કોઈ કારમાં ટ્રાવેલ કરીએ છીએ, આપણી હરવા કોઈ વ્યક્તિ છે તો એને તો આપણે રેસ્ટમાં જ બતાવીએ છીએ because we both are traveling together. બટ કોઈ થર્ડ વ્યક્તિ જે કારની બહારથી જોવે છે, they will appear that we are in a motion, right? So now if I take a pen in my hand and put it up put it up in my hand, and if I drop it down, does the pen fall straight on the ground? Yes, it will fall directly straight on the ground. Then do the hands of a wall clock move along a straight line? No, they does not move along. So we can know that there are different types of motion. Let's recall some of them. So here is a video. Let's watch.
Types of motion. Watch this batsman play a straight drive to send the ball straight to the boundary. Now watch as another batsman lifts his bat in the air and sends the ball straight into the stands for a six. Did both the balls go straight? What kind of path did the ball take in each case? While the cricket commentator can use the word straight to refer to two completely different types of paths and two very different types of motion of the ball, engineers have to be more precise. In this video, we will explore the different types of motion that different bodies show. But first, why do we need to learn about different types of motion? Most of us love to ride a cycle. What if we want to increase its speed or make it easier to types of motion? Look at India's star athlete Hima Das running on the track. She is running on a straight path. This kind of motion is called linear motion. However, if the path is curved, then she will turn as per the curved path. When an object or a body goes along a curved path, it is said to be in curvy linear motion. What about this girl traveling in a lift? This lift can only move in a straight line without taking any turns. Such motion that strictly follows a straight path is called rectilinear motion. Are there any other examples of motion in a straight line? Look at the motion of this needle in a sewing machine. It goes back and forth in a straight line. Such motion that happens again and again at a regular time interval or a period is called periodic motion. It repeats itself after a specific time period. To summarize, we have learnt about two types of linear motion, rectilinear and curvilinear, and found that they may be periodic or non-periodic. In the previous video, we saw several types of linear motion. Now let us consider something different. How about a car moving on a circular racetrack? It must keep turning to remain on the racetrack. Such motion, when a body travels along a circular path, is called circular motion. In circular motion, the object is at a fixed distance from the center. Another example of circular motion is a child on a merry-go-round. Earlier, we saw that linear motion can be periodic if a body moving in a straight line repeats its movement at regular time intervals. This is also true for circular motion. Remember the circular motion of the child on a merry-go-round? The child moves along a circular path and comes back to the same point after a fixed time period. When a body goes around a fixed point periodically, such motion is called a revolution. The Earth moving around the Sun is a good example of revolution. The Earth completes one revolution around the Sun in a fixed period of 1 year. Note that the fixed point is outside of the body. Another type of periodic circular motion is when a body moves in a circular path around itself. A good example of this is our Earth moving on its axis. Such motion, when a body goes around itself periodically, is called rotation. Note that the fixed point is within the body itself. Now, let us come back to our cricket example. When spin bowlers spin a ball, it shows two different types of motion. Can you tell us which are the two types of motion this ball shows? A. Curvilinear motion, B. Rectilinear motion, C. Rotation, or D. Revolution. The cricket ball shows curvilinear motion, a type of linear motion because it travels along a curved path and also shows rotation. Sometimes bodies move in unfixed patterns. Such motion is called random motion. To summarize, we have learnt about different types of motion, each with its own property.
So let's discuss some questions. Why can't we use a handspan as a standard unit of measurement for length? You have to write these questions in your notebook and send me as an homework. This question are also added in the previous homework. We cannot use a handspan as a standard unit of measurement for the length because it is not same for everyone. It will give a different value of measurement when done by different people. What are SI units? What is the SI unit of length and time? The SI unit or International System of Unit is a system which specifies the standard unit of measurement. This is to make sure that people all over the world gets the same value when measuring the same object. So SI unit of length is meter and SI unit of time is second. To a person sitting inside a moving car, will the nearby trees appear to be at rest or in a motion? To, to a person sitting inside a car, the nearby trees will appear to be in motion. Identify the type of motion shown by the first, the blade of wings, and second, the needle of sewing machine operating at a constant speed. So first the answer is the blade of windmill shows circular motion and the needle of a sewing machine shows periodic motion. Let us recall some type of motion and match the following. Write this also in your notebook. A car moving on a straight road. Which motion does it follow? Rectilinear motion. Merry-go-round. Which motion does this follow? Circular motion. A simple pendulum. Which motion does it follow? A periodic motion. So write this all things in a homework. In today's lecture, we revised some concept related to measurement, state of rest, and motion of an object. We learned that we need a standard system of unit for measurement, and every measurement has two parts, a numerical value and a unit. And we can convert one unit of length to another and compare two quantities of length compressed in different quantities. Then we learned about the motion, different types of motion. Okay, so thank you students. This is the end of our lecture. Thank you all.